Hello and welcome to today's webinar. My name is Tyler Reid. I'm the Manufacturing Application Manager here at GoEngineer. And today I'm going to be showing what's new in CAMWorks 2017. CAMWorks 2017 just released a couple days ago, and it's been a pretty popular release throughout the beta process. It's geared mostly towards improving the user experience and the general usability of the software. We didn't get a lot of new features in terms of adding machine capabilities or new and exciting things. We got that recently with tolerance-based machining. That was released about a month ago, and that module is version agnostic. So it's not really specific to 2017. We can use it in 2016. And if you're interested in that, I do have a webinar out there on YouTube, CAMWorks Tolerance-Based Machining. 2017, like I mentioned, is more for the usability. Existing customers are going to love this version because it's going to make the programming experience better. We're going to focus on the general enhancements first, very quick, and then we're going to move into milling enhancements, and then we will end with turning and mill turn enhancements. As far as the general enhancements go, you can see right away that CAMWorks is now conforming to the SOLIDWORKS icon color system. SOLIDWORKS made a change last year in 2016 to the more muted color system, more blues, cool colors. CAMWorks is following suit. If you do like the classic color systems, you can change it back under CAMWorks options. Display, you can change the icon color back to the classic. That's going to require a reset of CAMWorks to take hold. Another thing that's going to be available in milling and mill turn and whatever portion of the software you're using is CAMWorks can now reference the SOLIDWORKS custom properties when it comes to feeding info to the post processor. So in the past, under the machine entry posting tab, we would have some posting questions here that we could input things like program number, customer, date programmed, general info. We can now actually tie that into the SOLIDWORKS custom properties under File Properties. And we can save that as part of our SOLIDWORKS template so that it's automatically going to load up each time we open and start a new part. Another quick thing here. Notice that in this part, I'm looking at mill part setup 1. This is actually a part that I've programmed many times, and I've erased the setups many times. And some of you may realize that when you do that, you don't always restart at mill part setup 1. If I were to delete this and rerun the feature recognition, it would create mill part setup 2, even though it's the only setup. And if you do that enough, you end up with setup number 20, setup number 25. CAMWorks 2017 is actually going to reset that clock every time now, so that's kind of nice. Last thing for the general enhancements, when it comes time to post-process this, after I save a location, the post-processing window is actually going to show up here in the user interface now instead of the new pop-up. It is the same screen. Some of the options are minimized, but it's just one less extra pop-up that we have to deal with, a little bit more in tune with the SOLIDWORKS interface. Those are the quick general enhancements. Let's jump into milling. I'm going to go to a separate part quick here. This is an LS7 motor plate. Lots of features, lots of pockets, holes. Very complex part. We're just going to focus on one portion here. We're going to talk about some of the volume mill enhancements. Remember, volume mill is the high-speed machining technology that CAMWorks utilizes for situations where you have to hog out a lot of material in very hard stock pieces. Volume mill is going to be the answer. And in this case, this is a perfect example of a part that would benefit from volume mill. It's a large part. And it's going to increase the machining speed on per feature 3 to 4 times. So I'm going to go ahead and create a new feature. and it's going to be a pocket. And instead of messing with the strategy here, if you notice, the default strategies have changed in 2017. 2017 got a reboot in the TechDB. The default TechDB that loads with the software is much more robust than previous versions. And I do have a strategy here that roughs out with VoluMill, does a second rough pass using the rest feature, just hitting where there might be material left over, and then it does a finish pass. But I'm going to go ahead and just pick course. I'm not going to run this through the database. Instead, I'm going to act as if I am revisiting a feature that I want to add a tool to. So in the past, we would go to our feature, we would right click, and we would select new 2.5 axis mill operation. And in this case, it's going to be a rough mill. And in the past, we had two options. We could use the TechDB default, which didn't really look at the size of the feature when it came to tool selection. It would just give me a generic rough mill. Or I would have the option of copying from an existing rough mill. What's new in 2017 is in the defaults, we can actually set up multiple defaults. So you can see here, I do have the default, but I also have cavity machining, core machining, and VoluMill as options. And so even though I'm not actually running this through the database, I can access strategies that are going to get me closer to the final outcome that I want. So by selecting VoluMill, you can see the roughing defaults to VoluMill. There's a couple improvements in the VoluMill module. Firstly, under the Feeds and Speeds tab, we now have a VoluMill Technology Expert link. And this is going to help us determine the feeds and speeds for VoluMill. This is very nice. In the past, we had to go download the Technology Expert, which admittedly was hard to find because it was discontinued by the writer. So now it's integrated into CAMWorks. You don't have to download it. And we just use a few drop downs. It actually pulls from the material. It pulls the material information from the file. So it looks at the stock. It pre-fills in the material selection. We can set up hardness, coating on our tool, the holding quality of our fixturing, our machine taper, and the tool type. And then we are giving conservative and we are given aggressive feeds and speeds, and we can use this slider to adjust between the two. And that sets our feeds and speeds. So VoluMill users are going to see much faster programming when it comes to actual determining the feeds and speeds. As far as the nitty-gritty details of the VoluMill toolpath, those are still accessed here, but we have a couple extra checkboxes. We do have this full entry spiral checkbox now, and we have avoid sharp corners for repositioning. So I'm going to go ahead and preview this toolpath. And what we're looking at here, notice the entry, it fully spirals down to the very bottom. So this is new. So now CAMWorks, when it enters the pocket, if you have that box checked, it will fully spiral down into the bottom. And then notice here we have these rapid moves that are sharp corners. That's hard on the machine. So we have the avoid sharp corners for repositioning option. That will round those. Okay, so in certain cases when the tool had to move from one area of the pocket to the next, you would see sharp corners. And that was very tough on the tool, very tough on the machine. So now we can avoid those simply by checking that box. We're going to go ahead and jump back over to the last part. This is a part that I did run feature recognition on already. and I wanted to point something out. Let's go ahead and recreate a feature. We'll recreate one of these pockets. We'll set the depth back to the face, and we'll choose the rough finish strategy. So now when I run this through the database, and I select on this rough mill that it had selected, notice it selected an 1/8" tool. And in the preview, while I'm in the tool tab, we get this yellow dotted circle. That's new. So this is what CAMWorks is calling the largest inscribed circle. It corresponds to the largest tool you can fit inside the pocket. Okay. And they're using this to help them choose a more appropriate tool when it's based on the feature size. So in the past, when you had a feature, if you were basing the diameter of the tool on the feature size, it would look at either the total length or the total width of the pocket or the finish radius of the pocket. And that sometimes would give you tools that were too large to actually fit inside the pocket at all. If you imagine a pocket with many islands inside of it, or say like an O-ring groove modeled as a pocket, the tool would never fit. So now this is a more efficient and actually more intelligent way of selecting tools. Largest inside radius. Largest inscribed circle. Okay, let's take a look at some of the existing toolpath. For example, this contour mill around the outside. More and more people are moving back to the old method of inputting the entire tool radius in the tool offset on their control. So in the beginning of CNC, it became very popular to use the CNC comp as a programming tool. Right? So if you had a 1/4" tool in your comp offset, you would put in 1/8", your full radius. And then people moved away from that, and it ended up being used as more of a wear offset. So if you had a 1/4" tool, you would measure the distance or the diameter difference from nominal, how much has the tool worn, and you would put that in as your wear offset. But nowadays, more people are using probe systems, such as the Haas system, that wants to default to using the full radius of the tool. And so what would happen is users would have to output code without compensation. And that means instead of outputting the dimensions, XY dimensions, offset from the walls, we would actually output dimensions that were on center. Okay? And this is what the old methods would look like. Now the issue is this type of situation here, where the corner that we're going to cut could not actually offset based on our tool size. And so you would get toolpath that was undercut or overcut. So CAMWorks 2017 now allows us to deal with that by allowing sharp corners when we are programming with CNC comp on and the toolpath center without compensation. Now you can see we have our nice tight corner in there. And that's going to be a more appropriate toolpath when you're using something like the Haas probe. Speaking of toolpath center, if you are programming that way, we can now accommodate for that in thread milling as well. So if I come back to one of these holes, we add a thread mill. Notice in the TechDB defaults, I can now choose thread mill. We have this area active now as well. We can go with or without comp, and we do have the sharp corner options as well. So if I were to preview this with comp, we get this, and without compensation, we get this. So now we're relying on the offsets in our controller to push that toolpath towards the center of the hole. When it comes to lead ins and lead outs on situations like this, where I had several pockets that were found separately, I ran them through the database and then I combined operations. Now I'm controlling several pockets all with one entry. In the past, it was difficult to control the lead ins and lead outs separately, and that interface has been improved. So under the lead in tab, notice I have a drop down menu for all of my individual pockets. Whichever one is currently highlighted displays in blue. See the blue dot? And all the rest would display in red. If I were to make a change in these numbers, they would only apply to the pocket that I currently have selected, unless, here's the new part, I check this box. So if I check this box, they are all linked together. If I uncheck it, they are treated separately. Let's talk about the improvements in creating multi-surface features. The blade on this knife would be a multi-surface feature. Whether we do it in 3 or 5 axes, it's going to be a multi-surface feature. Now we have a new way of creating these features based on surface finish callouts. I mentioned before the CAMWorks tolerance-based machining. Tolerance-based machining, if you haven't watched the webinar yet, and if you're not informed on that, it uses PMI data or DIM expert data, say MBD or model-based definition data, to help us determine machining strategies. For example, if we had a hole with a DIM expert tolerance on it, we can use that tolerance to set the machining strategy. The tightest tolerances we might give to a ream cycle. If we have looser tolerances and we set the threshold, say if the total tolerance is 5 thousandths, then it suddenly becomes a drill cycle. If the total tolerance is 3 thousandths, it becomes a ream cycle. So we can read that data. Another part of MBD data is surface finish callouts. And now we can use surface finish callouts to create features. So for example, I have a surface finish callout on this blade. When I go to create a new multi-surface feature, my options in the past have been selecting faces, using the all displayed option, choosing an STL file, or faces by color. The new option, the fifth option we now have, is faces by surface finish. So when I select that, I get a list here of all of the different surface finishes I have in my part. I simply select which one I'm hoping to create a feature out of. So if we're doing mold machining, where you might have several different surface finishes throughout the part, all called out in the 3D model, this would be a very quick and accurate way of ensuring that whatever strategy we're using to cut each part is tied directly to the surface finish. So I've already gone ahead and created that feature. I did not. Let's go ahead and create that feature. Multi-surface feature. We'll go by surface finish. And I'm going to select the 5-axis strategy. That will create a multi-axis mill. Multi-axis mill has seen some improvements. Go ahead and double click into this. Let's get some quick toolpath on here. I'm going to choose a smaller tool. We'll use a 1/4 inch. When I create multi-axis mills, I usually like to go to the axis control tab first. I'm going to keep this as 5-axis, but I'm going to go normal to surface. The next thing I'm going to do is go to the pattern tab, and we'll choose flow line between curves. We'll choose the upper curve here and the lower curve here. So my toolpath is going to interpolate between those two curves. We're going to avoid cuts at exact edges. That's the preferred option. In the entry and retract, looks like our clearance plane is in Z. That looks good. We'll go ahead and give this a shot. Not too bad. So there's a couple things I wanted to talk about in multi-axis mill. First is in the posting tab. Notice we have a whole new area down here below. These are multi-axis parameters that have really been necessary in the past, but missing from the CAMWorks user interface. So every individual post writer would actually have to customize each post they wrote to include this data. It was a lot of overhead to keep track of and a lot of editing and a lot of logic written on the post side. This is now all integrated into CAMWorks, so it's going to make post writing a little bit simpler. It's going to give you a better user interface to actually set these numbers. Issues with the tool repositioning, interpolation, the machine limits, those were all done through questions up here in the top in the past. Another option we have added in the multi-axis mill is under the finish tab, we have this exact step over option. Now exact step over actually disregards the slope of the wall that we're machining and still does the same step over. So in the past, this image may be difficult to see, but in the past, you can see over the top of that image, the XY step over actually gets spaced out. XY step over would space out if the slope of the wall shallowed out. And XY step over would become more dense if the slope of the wall increased. This exact step over does the dense step over through the entire part. Actually gives you a little bit more consistent surface finish. On this part, the slope of the wall is actually not changing at all, so I don't believe it would affect it. One last thing I wanted to point out in milling is the rebuild message. This could actually be listed under the general enhancements. But if we were to come back to SOLIDWORKS and make a change to one of these features, we will say increase the radius on these holes. And we'll just do a couple of them. They're not linked. When I move back over to CAMWorks, it would warn me, and I would get a pop-up that looked very similar to this. It would have the full, the light, rebuild options, cancel, and help. but it was always difficult to remember what the difference was between full and light rebuilds. And so they changed this warning box to explain exactly what a full rebuild means and exactly what a light rebuild means. Of course, it means that full rebuild recognizes and adjusts both the automatic feature recognition features and also the interactive feature recognition. The light rebuild would only look at interactive features, so features you created on your own. That about does it for milling. So we're going to jump over to turning and mill turn. Let this recalculate. Okay, so these enhancements that we're about to talk about on this part, if they're turn related, they will show up in both turning and mill turn. And if it's mill related, it will only show up in mill turn. So the first thing I want to talk about, and probably my favorite enhancement to turning, is the new control and new options we have over the chuck. So notice right away that the chuck I have displayed here and on this side as well is not your standard chuck. This is actually a 12C collet of the exact size collet I plan to use on this part. Okay. So how do we do that? Under the machine tab, chuck and fixture subtab, we have a few options now. Instead of just the standard chuck that we've always used in the past where it has some templates built in and you can choose how many jaws and select the jaw sizes, etc. We now can use a SOLIDWORKS part or a SOLIDWORKS assembly as our chuck. Okay, so the chuck that I'm using, I can actually open it up. It's an assembly. And I assembled this using the exact size collet I plan to use. Okay. So I can set that up exactly what it's going to look like if I have soft jaws or some sort of custom holding fixture. That's going to be a bonus when it comes to simulating and gouge checking against the chuck. I would read that in. When I select that assembly, it also allows me to select configurations of that assembly. So I might have a different configuration, in this case, corresponding to every collet size. And if I have multiple coordinate systems in there to help me align this chuck correctly, I can set those up as well. That would read that in, and then I might do some further editing later on. I'll show you here in a second. Notice I did set this up for both a main spindle and a sub spindle. I happen to use the same chuck, but that's not necessary. Also new in this window is a more complete control over the distance between the home positions on the main and sub spindle. We have both a distance here and also a reference. That's what was missing in previous versions. We would set a distance, but we didn't know what we were actually referencing between those. Is it the front of the chuck? Is it the back of the chuck? Etc. So now we actually have that control. Okay. One last thing in there. Once I have this selected, I can edit and I can choke up on the part. Right now I'm choked up 1 inch. Notice as I adjust this, it's choking up on the part. So I can position this chuck exactly how I need to. And it's a very visual representation. Okay, part of the benefit of reading these more accurate chucks in is a new option on the turning side. If we go to, say, the turn rough, notice we get some toolpath. In this case, there's no threat of colliding with the chuck. We can see that. It's very clear. But that's not always the case. So now in the turn operations, under the Advanced tab, we now have chuck and fixture avoidance. So along with reading in a more accurate chuck or fixture, we can also now avoid it. So if we enable this, we give it a clearance and we get a line showing where that clearance value is. So if I were to give it more clearance and hit preview, we can see my toolpath now pulls back. This is going to be extremely handy for all turn and mill turn users. While I have this turn rough up, let's talk about some of the enhancements in the turning. Under the Feeds and Speeds tab, well, we actually have a Feeds and Speeds tab now in turning. So that right away is different. This makes it more consistent with the rest of the program. Feeds and speeds, so we can select surface feet per minute or RPM, just like we could before. But what we couldn't do before are calculate arc feed rates and also create overrides for the entry and the exit, first cut, and final cut. We can do separate feed rates for all of those, and we can also specify a feed rate specifically for arcs. So we have a lot more control over our feed rates throughout the toolpath. And a very nice interface to see what we're doing and what we're setting. Under the NC tab, this looks different as well. We have, again, a better interface for what was existing and additional options on top of that. So now we're talking about the approach and retract strategy. Okay, we have approach here on the left and retract on the right. Under approach, we can do Z then X and X and Z in direct. Nothing new there. But on the retract, we can now do Z then X, X then Z, but also X only or Z only. So imagine a boring bar. We can now exit straight back in Z on a boring cycle. Okay. We also have a better interface for controlling our retract and approach points. So for example, we can approach from, we can set this to auto. We can actually approach from the previous tool retract point, and it would figure that out for us. Or we can set an approach point, and then under the approach point, we can set up a reference and then an offset from the reference. Or we can hard code in a value. Okay. On the retract, we can set this to auto as well. Now, auto in the past was a little bit unreliable. A lot of work was done to rewrite the logic for this auto setting. And going forward, auto is probably going to be the best option for most users. But you can select other options. We can do a preset position, X and Z. We can go to a retract point. We can go to a retract point and then the preset. And the preset is tied into the machine parameters posting tab. That's similar to what we used in the past. Or we can go to none. And we also have this box, go to home on tool change. Okay, so all of these are a lot of new options. It also includes a gouge check on the retract. This is much improved and it's going to be a very welcome change for current turn and mill turn users. I should also note, now that I think about it, when it comes to this feeds and speeds tab and setting the surface speed RPM max, we can do this on a per operation basis. So if I'm using the surface feet per minute, in the past, we would set a RPM max in the machine definition in the TechDB, and that would be universal. You could not change that. But now, because we have these more options in controlling the speed, we can actually set the surface speed RPM max on a per operation basis. So you can imagine if a situation where, maybe you're turning a very large part, and as you remove material and you reduce the mass of the part, your machine might be able to handle higher and higher RPM. We can now account for this. So in the past, you were stuck with it. You're never going to turn it faster than on the last operation than you were on the first operation. Whereas now we could take that into account. When it comes to threading, we can actually thread multiple segments all in the same operation now. So if I were to create a new turn feature, it's an OD feature using the thread strategy. I can now select this segment and this segment because they're collinear. Okay. I couldn't do that in the past. In the past, if I were to accept the feature at this point, then it would scream at me. It would give me an error. But now it actually lets me create it. And generate toolpath for it. And it goes across the gap here. Okay, so that was not possible before. The only thing we could do before is we'd have to create a feature for the first segment and a feature for the second segment, and we would not be cutting them at the same time like we are here. Just to give you guys a walkthrough of what we're doing in this part, I think it's pretty well done. Let's turn the chuck back on. So imagine we have this, being loaded up in a bar feeder. The stock is about 1.5 inch diameter. We've got the 12C collet on here. We rough and finish the face. We turn the OD. Then we do a subspindle grab and pull. So the subspindle comes and grabs the part, pulls it a short distance. Let's get rid of that thread. And then it does a cutoff, and then the subspindle goes home. And then from the other side, we do our milling portion. All programmed using CAMWorks mill turn and the subspindle operations. That about does it for what's new in CAMWorks 2017. Like I mentioned, it's not a release that is geared towards, creating headlines and saying we've added a lot of new functionality. This is a more toned down release, I would say, geared more towards current users who needed a better user experience. And I think this is going to do that, especially for the turning enhancements. Turn users, there's a lot of that we were able to do within the post. Now we don't have to, and new users going forward will never have to worry about highly customized posts for some of these options. Now, having said that, there is a new module for CAMWorks 2017. It was released last month. It's called CAMWorks Tolerance-Based Machining. Again, check that out. It's online on our YouTube page. That is new and that is headline grabbing, but it's not tied to CAMWorks 2017. It can also be used in CAMWorks 2016. So I want to thank you guys for joining live. This will be up on YouTube shortly. We're working on getting a lot more YouTube videos up on our channel. If you have a suggestion, If you'd like to see videos maybe on a particular industry, or if you'd like to see in-depth infos on, something that you are doing day in, day out, let me know. My email is treid@goengineer.com. I'd love to get suggestions from you guys. So thank you for joining, and I'll see you next time.